get the same answers from each other's information. And it can take us an embarrassingly long time to get the same answer, I have to admit. But once you've done it, you then can sort of put your hand on your heart and say, yeah, I believe this is right.
I guess you end up training each other, I guess.
Indeed, yeah.
Okay, so along with that line, if you happen to have had a few $1 billion lucky funding for an area of research that you would want to go into, but it has to be in Australia, for example, what would you choose or build or do? What would you go for?
Well, if you said I had to spend it in Australia, there's only one answer to that. That would be to fund the new international radio telescope called the Square Kilometre Array. That's going to cost that sort of money. And Australia is one of the two best places in the world to put that. It's not funded yet. It's not decided it would come to Australia. So I need that $1 billion so we can fund it and build it. Why is that so important? It's a complete, it's an incredibly large step in building a bigger radio telescope than we've ever seen. And what it will actually do is let us see further back in time with radio waves. It will let us see further detail with radio waves to do things we've dreamt about with optical telescopes, but never had the capacity. The current radio telescopes do some very clever things. They give us high detail by triangulating with separate antennas a long way apart, and the radio waves can see through dust. But the antennas are so small, and there's so little energy in radio waves that we can't see very far. The Square Kilometre Array is building up an antenna with a collecting area, a square kilometre in size, and that's going to let us do all these wonderful experiments right back in time. Things like, I was talking about the cosmology experiments, looking for these wiggles. We can do that across the whole universe in exquisite detail. We can look at when the first galaxies, the first stars formed, look at their hydrogen gas, because it gives off very faint radio waves way back in time, and we don't need to care about the dust that hides all that early star formation from optical telescopes, because the radio signals go straight through. We can potentially, with the Square Kilometre Array, look inside the dust where new solar systems are forming and pinpoint where Earth-like planets are actually forming. Not just find them, but actually see them forming. Exquisite information. We can use this telescope to make incredible tests of general relativity.
And I agree with that. That's a hell of a project. And
there's one thing I must say. I think you did you say I could have $2 billion?
Several.
2 billion?
Several.
Okay. I'd spend $1 billion on the telescope, and have the other $1 billion to seriously fund research institutes and fund the salaries of the people to do the science. You can't just build the telescope. You've got to fund the people, the clever people, and bring them here to do the work, get the results. That's absolutely essential.
I thoroughly agree with that. That's you can't get anywhere without the people doing the science. Just one thing with regard to, I think you were alluding to the SKA with regard to resolution. What sort of resolution are these? Will the project be able to actually achieve that is over and above what we can currently achieve? Angular resolution.
Oh, you're asking me a difficult question, huh?
Sorry, just in case you happen to know, would it be sort of like sub-arc second?
Okay, I work in pictures since I can't do the calculations in my head quickly. So with the best optical telescopes, and the best technology to create the atmosphere, you might be able to just see a planet next to a star. Very, very tough. And we can only see big planets. I think we're looking at, so that's probably sub-arc second resolution with the best optical telescopes with adaptive optics fixing the atmospheric distortion. Right. With the radio waves, I think you're looking at 100 tons finer detail, so you can see that planet assembling from its constituent pieces eventually.
Good God, that's indeed technically amazing. But the one thing I actually did hear about the other day, which was somebody had done a calculation which, if you actually put in one pot basically all the radio energy ever accumulated, it would be the equivalent of a feather being dropped from 1 meter. So these instruments certainly have to be pretty fine-tuned and big.
That's the thing. This telescope, if we get this funding, is going to have a large area to collect enough energy to overcome that problem that the individual radio signals are weak, and it's going to be in antennas that are separated by long distances, so you can triangulate and get that incredibly fine resolution. It will rely on computer technology that we don't yet have. It's very ambitious, but it's already pushing that technology, and I heard that the CSIRO is building a prototype, just a small test facility, and that development in WA is already driving the fact that the first link of Australia's broadband IT network has been preferentially put in between, I think, Perth and Geraldton as part of the backbone of where they're going to feed the data from the telescope in rural WA back to Perth where they process it.
Indeed, I heard that they had some good results there too.